Hello, everyone. Welcome to Catalog and Cocktails, presented by Data.World. We're coming to you live from Austin, Texas. It's an honest, no BS, non salesy conversation about enterprise data management with tasty beverages in hand. I'm Tim Gasper, longtime data nerd and product guy, joined by Juan.
Hey, Tim, I'm Juan Cicada, principal scientist at Data.World, but I'm coming here live from Playa del Carmen, Mexico, outside of Cancun. This is luckily it's my second home here, and I get to spend some time. So that's where I'm right now.
Two locations live today.
Two locations live. So, but today we are going to have a fantastic conversation on, Wednesday, middle of the week, end of the day, with this guy who I met fairly recently, meaning like in January. And what was funny is that our first guest of this season was Sarah Canzaro, and we asked our guests who should be our next guest. And she said, you should talk to Chad Sanderson. And what was funny is that literally the day before our podcast, I had met Chad. I don't know how we met, connected. I think it was through LinkedIn, and we kind of said, hey, we should talk about it. And I'm like, I met Chad. I'm like, oh man, this guy's awesome. He is. Oh, first of all, Chad is the head of data product at Convoy, and I would call him like the honest, no BS LinkedIn celebrity right now. Like when Chad writes stuff, everybody is on it, and sometimes the people tell me that Chad guy kind of doesn't like the modern data stack. He's kind of a hater on it. I'm like, he's bringing up all the things we should be talking about. So don't hate on Chad. We got to go listen to him. And that's why we're here. Anyways, Chad, a pleasure. It's so cool to finally have you on the show. And we finally got to meet in person a while ago. So cheers. How you doing?
I'm doing great. And thanks for having me here. I've listened to the show a lot. Big fan. So excited to defend myself from all the haters.
Well, before we'll have a lot to talk about. So, but let's kick it off. So what are we drinking and what are we toasting for?
You can get off. Today I am drinking Health Aid Kombucha, quality stuff. I'm not a huge drinker, but my stomach has been upset for the last week, and this tastes awful, but it works.
How about you, Tim?
I struggle with kombucha. I want to like it. I really do. But I'm drinking raspberry cranberry gin fizz. So.
Wait, how's it a cranberry? It's not red.
It's not red. It's colorless.
So colorless cranberry.
Yeah.
Interesting.
Pretty cool, huh?
Well, I'm in Mexico, so I'm having a Mexican beer, Bohemia, really nice, crisp Pilsner. And cheers to I'm 2 blocks away from the beach, so I'm just having a nice workation. That's cheers for me. So how about you guys? What do you want to toast for?
Cheers to finally being on this podcast with you guys.
All right.
It's been a long time waiting for that. Awesome. So we got our warm-up question. It says, getting data architecture right often requires paying down legacy debt. What's something you recently purchased that you maybe shouldn't have?
Yeah, good question. So my team is the data infrastructure team at Convoy, and we don't make a huge amount of purchases, but we do build a lot. We're a pretty heavy software engineer driven organization. And about 2 years ago, maybe a year and a half ago, we spent a lot of time building out all these various components of our machine learning stack. And at the time, it was great. We were solving a real problem, a feature store. And right after we built it, maybe 3 months later, big company called Tecton ended up raising their Series A. They're on their Series B now. We didn't have the resources to keep supporting it. We got pulled into 10 different other projects. And this big thing that we had spent, 6 months building and trying to get people to onboard to, we just had to shelve. So that's like the perpetual merry-go-round of owning a software engineering team in a developing space. But we find ourselves in that position from time to time.
I like how you went to a serious answer to that, which is this is something we should be talking about, build versus buy. But no, it's good. You're ready here to go talk about data and stuff. But
I'm a serious data guy. That's all I think about.
How about you, Tim? Do you do non-serious data things
You
like
know,
buying something that you shouldn't have?
well, once you started talking, Chad, I was like, man, I wonder what my serious answer to this would be, because I was only thinking of it in sort of a more fun and joking way. And I'm like, well, what purchases have we made recently? I'll say my funny answer is that I really got obsessed with the idea of whiskey glasses and then having special whiskey ice cubes. And I went a little too far with that. I've got like 4 different kinds of whiskey glasses now, and I've got like 3 different size whiskey ice cubes. Because what happens, the problem, I didn't realize this was a problem, is that you have to make sure you create the right combination of the shape of the cup and the shape of the cube, or else you get weird, awkward things where the ice cubes don't match. So that's a little bit of maybe a recent purchase that I should have did a little more diligence on.
My quick one is when I bought my house, I said, well, there's a yard. I bought a lawnmower, right? Because I'm gonna take pride in my house. So yeah, I think I used it probably once or twice. I'm like, I'm just paying somebody for this. So yeah. I think it stayed in my garage for like 2 years before like my wife said, we're gonna get this out and I mean, I don't know, go sell it and buy a bottle of wine with it or something. So that's what we did.
I still have a
But
lawnmower as well, and the other day I was actually thinking of pulling it out and using it, but then I
yeah,
was like, but I haven't used it in like 5 years. I should probably maintain it. I probably need to like re-oil it and stuff, and it seemed like it was too much pain.
well, all right. Enough about lawnmowers. Chad, honest, no BS. What's wrong with the modern data stack?
Oh, where do I start? I think that the modern data stack is solving a real set of problems, but it's solving them out of order. It's the best way to put it. So, I'm sure we're going to get into all the history on this podcast. So it'll be interesting to do that. But when data moved to the cloud and we had that nice separation of computation and storage, Snowflake started exploding, Databricks started exploding. The cost of storing data went down dramatically. What the position a lot of teams found themselves in is like, okay, now we don't have to worry nearly as much about all the data that we're storing. We don't need to focus as much on optimization. So what we really care about is all those downstream business use cases and ensuring our data scientists and our analysts and our executives can answer every single question they need to answer under the sun. And we need to get that data to them as quickly as humanly possible because we're a fast growing startup and we have a ton of engineering services and we have a ton of data. So let's just use ELT, let's throw it all into the data warehouse and pipe it downstream, transform it a little bit. Maybe we'll have some layers of governance. Maybe we'll get data engineers to do it. Maybe we'll get some data people to start doing some of these transforms in quote unquote data marts and business intelligence schemas and things like that. And once we have all that data, let's build the modern data stack on top of that system. Like that, what I just described, the swamp is the foundation. And every tool in the modern data stack sits atop that swamp. And if you build things on top of a swamp, it sinks. And that's where we are right now, in my opinion, with the modern data stack. We have this extremely messy foundation, a completely broken data warehouse, and we're sticking product on top of that.
We've talked many times, Chad, and I don't think we've had this specific definition. You haven't brought this, and I love this. And I think this is the honest, no BS stuff that we need to start realizing. We are defining all these categories, all these tools, and doing all this stuff because we decided to build everything that we're doing on top of a foundation, which is a swamp. We're supposed to build on the shoulders of giants. That's how we advance knowledge of mankind. We do science, right? But for data, apparently not, right? We decided this goes back to the conversation I always have is about efficiency and resilience. And we've been focusing on just being efficient, just dump that stuff, just get to me quickly. And now apparently I want to go build a resilient thing off of something I just did very efficiently. I think this is something that we need to start really acknowledging that we're on top of a swamp. And that's why we're just going to put more Band-Aids on top of things.
Well, I think we got to dig into this a little bit, right? Because I think one of the things that's appealing about the modern data stack is seeming simplicity, right? This idea that like, well, I've got my sources, And I can't control the sources. Let me get it somewhere I can control. Let me bring it into my playground, my data warehouse, or my data lake, or my data lake house, or insert your favorite thing here, right? And then from there, let me shape it. Let me build my castle once it's finally in my playground here. And then from there, now I can visualize it or interact with it or query it, right? And seemingly it seems simple. It's like grab all the things, shape it the way I want, visualize it, right? What are we missing here about this being a simple answer?
Well, I think as with most things, the devil is in the details. Where is that data coming from? Who owns that source data? How does it get there? How is it transformed? How frequently is it transformed? And who owns the transformations? That set of questions, when you're moving quickly, oftentimes don't get decided up front. In fact, very rarely does it get decided at all. So if we took a very specific example, something that's become really popular with the modern ELT approach is change data capture. And if you're familiar with change data capture, usually you have some production database, maybe it's Postgres, maybe it's something else. And each row in a production table stores entity data. So there's a service. The service is creating some entity concept like a user, or in Convoy's case, it might be a shipment or a carrier or a shipper or something like that. And there are some dimensions, some properties that are associated with that, with every unique entity. That is owned by the application engineers. And the way that they treat that data is it's for their application, right? It's like, I'm going to add all the properties that I need in order to run my service effectively. And because it's the implementation details of the service itself, they have to be free to change that as and when they need it. They can't be bottlenecked on a downstream consumer to change their own service. And what we've said is, well, that data is really important. So what we should do is we should use this really cool thing called CDC, and we should capture every time we get new information in one of these production tables, and then we should pipe it into Snowflake, into the data warehouse, and we should do all of our joins exactly as you've described, Tim, downstream. The problem with that approach is there was never an agreement by the engineering team that it was okay to do that. And if you go and talk to your engineers who own these production tables, what almost all of them are going to say, in fact, I would say virtually 100%, they will say, do not take a production dependency on this data because I can and I will change it. So if you're building your queries on top of these components that are owned upstream and the engineers are saying, you can't do this, don't take dependencies on this, you will end up being broken downstream. This is something that happens at almost every single company that I've talked to. And as machine learning becomes more and more critical to business operations, it simply is not acceptable for a model to break because an upstream engineer decided to change something. So that's one example of a failure when you're really focusing on the details. Another one is in this world where you're doing a whole bunch of transformations. Let's just put aside the fact that, there's the upstream stuff, it's breaking, blah, blah, blah. But when you aren't deciding what data you're recording from production and you're dealing with these implementation details of the service, it's never going to be perfect. It's never going to be all the things that you need, right? It's going to be some things that the application needs to run and say, okay, I can deal with some of this. And the data scientist or the data consumer is always going to have a gap, a delta between what they need to answer the business question and what actually exists that's coming from production. And this is where SQL comes in, right? This is where people start writing queries. They do a whole bunch of joins. But depending on how complex the question is, you are going to have an equally complex query. Because you're not actually capturing the real world information directly, you will have to infer what's happening through SQL. And that could result in a 100-line, 200-line, 500-line SQL query. And that 500-line SQL query, just by definition, is never going to represent the real world accurately, number one. And in most cases, many of those huge SQL queries actually have tons of joins, going on as well. So you get into this situation around opacity, the opaqueness of the table. It becomes very, very difficult to understand what this query is actually doing. And then on top of that, if we layer in the fact that a lot of the data people that are writing these queries in the first place, they're not trained software engineers, but they have software engineering tools. And this is something we can get into. It creates a real problem because there's not really a great culture of documentation. There's not a great culture of testing. There's not a great culture of monitoring. Many of these teams are not set up in such a way where there is a clear data on call at the team level. And so when things break, because inevitably they will at some point, because these queries are extremely brittle and they don't scale, and the upstream is always changing, it's not clear who actually owns fixing that or what the root cause was. And so you have got data people running around all over the place, spending hours and hours and hours trying to understand why a single query changed. And those two things together, in my opinion, are the core of what creates data quality in the data warehouse, and it's not scalable.
Okay, so this is spot on. I fully agree with everything you're saying, and I would argue that most people listening here will also agree. So, but three things come to mind. One is, what's the alternative? What are we supposed to do?
Yep.
Wait 6 months to get this perfect 6 months to get a simple dashboard? What? All right. So this we'll get to that. Second, where does this business logic, this knowledge live? Where does that live from the technical perspective, right? From the technology, where is that going to live? And also tied it to the third point is, where does this live? This notion of ownership or responsibility, where does that live? We talk about producers, we talk about consumers. We're not talking about data products, a data product manager. That's where I think it's going to live. But even that is kind of still being loose because where do those folks live within the or the chart, the organigram chart, and the domains and all that stuff. So three things I want to get into. What's our alternative? Where does the logic live from a technology perspective? Where does the logic, accountability, responsibility live from a people perspective?
Yeah. Great set of questions. So before we answer the first question, because I think that hopefully the alternative becomes apparent as we answer the other two questions, or maybe it flows more naturally in that way. The first problem that I think the biggest problem that you identified was, where does all this stuff live? If it's not going to be in the data warehouse, if it's not downstream, that's not where it's happening. Where should it be? It's a great question. I think, and this is something you and I have talked a little bit about before, is that there needs to exist a concept called a knowledge layer or a descriptive layer. And that descriptive layer or knowledge layer should basically be as close to a representation of the real world as humanly possible. In the old days, so, 90s, early 2000s, before all this cloud data warehouse and modern data stack and all these really like new fancy great technologies came around, that was something that a group of data engineers or data architects put together, entity relationship diagram, very common way of doing it, where they sat down and said, what is our business? How does our business work? What are the core entities in our business? What are the core events that we care about that are happening to those entities? And what are the relationships between those entities and each other? And I think that surface needs to exist. There needs to exist a surface where someone can define the business concepts, what those business concepts mean, and what the data that we are recording from production should be that's germane to those concepts. And in terms of who owns that, I think the business should own it. Now, I don't know if it should start there. I think like all things, if you're coming from like one system that's one way, suddenly transitioning ownership to a totally different group of people is really hard. But I think in the beginning, it's going to be the data consumers who own that. And the reason why is because they're the ones who need the data. They're the ones who understand the data that they work with. If you're a ML engineer or you build out feature sets, you know the derived attributes that you need. You know the data that's important to you to train this model. If you're an analyst and you need to understand, we have 3 different types of shipments at Convoy, and I want to know over the last 6 months, how did those shipment categorization splits change? You know what shipment categorization means in the real world. You may not know always how to represent that accurately through SQL effectively, but you know the business definition. So that's where I think ownership should be. So maybe I'll stop there for a second, and then we can start talking about applications.
So I got a comment that I want to pass it to Tim because I know he has more things here going into just looking at his face. So one is people who are listening right now, I would say the older folks, they're like, this is what we've been doing for so long. And why did this get lost? Like this, you're not saying anything new.
Nope.
So why isn't this happening? Why did this get lost to go to that? So that's the question that I'm going through right now. And then second, what I want to go dig into is like, how do we actually go do this? I mean, heck, I've dedicated my career to go focus on semantics and knowledge graphs and semantic layers, and it's still hard to go do, right? Mm-hmm. And I'm not going to get salesy, but for quick parentheses, like we've been doing this at Data.World, and we're working with customers to do this, but it's still not there, little by little. But like, is this going to happen, right? So, anyways, that's going through my head. But Tim, you're going in circles right there.
No, I mean, I think Juan knows when I like do like the touching my face and I'm in the praying motion that like I've got thoughts going on. But for those who are listening, you don't get the visual, unfortunately. But one question that's coming to my mind here is I'm just thinking about like, so there's 2 forces I see kind of pushing against each other in what you're talking about, Chad, and I'm curious about how you navigate that. One is like, okay, well, if the data is coming from upstream, and if these applications, if the engineers and the folks that were generating this data did a smarter job of sort of knowing how the downstream consumers want to consume that data and what the reality needs to look like, that's sort of one thing. That's like, okay, let's push more of that responsibility to design, architect, and have product thinking upstream, right?
Mm-hmm.
But then you made the statement that that the business and the consumers should own the data because they understand and they want the data. So I guess in my mind, I'm thinking about the tension between the downstream consumer and the upstream producer. How does that jive together in your mind in terms of how that all shakes out?
Yes. So I think both of your questions are related to each other. So I'm going to try to answer them in one go.
Yeah, sure.
So the first set was nothing I'm saying is new. All the people who have like, all the DBAs and everybody else who's sort of grown up like doing this stuff for the last like 10 or 15, 20 years, has been a data engineer for a long time. No, this is all like, this is my job. This is what I do all the time. That has gotten lost. And the reason it's gotten lost is I'm going to point fingers. Very big, important tech companies, Google, Facebook, Amazon. And the reason why it's gotten lost because of those companies is because the startup-centric model is diametrically opposed to the take your time and clearly build out your data model approach. They are going in 2 very different directions. The startup model is, who cares about the data? We need to move fast building services. We need to have a bunch of engineers moving quickly, rolling out with MVPs, validating that this product makes money as quickly as we possibly can, lowering our CAC, lowering all those different things. That becomes the first priority of the business for the first like 3 to 5 years of the company oftentimes. That's what Amazon did. That's what Facebook did. That's what all these folks did. And what they did later is say, listen, we have a bunch of data. We're going to dump it somewhere and we can figure out what to do with it when we need it. We can bring in data analysts as and when we need to, and their job is going to be to like clean up the mess, right? You're going to go in, we have a bunch of crap. Our executives needs to know, tell me this number, that number, or whatever. And it's going to be your job to spend 75% of your time building out these data models and answering that question, doing what I would call reverse engineering business concepts. Now, at one point in time, it was only these top tier tech companies that took that approach. But those companies grew. The software engineers and the data people who worked there went to work at other tech companies. And the software engineers and data people who worked there went to found their own companies and then hire them. So if you look at the tech space, which I think can be pretty incestuous at times, the way that we think about data all stems from this Adam and Eve, Amazon, Facebook, Google type of thing, you know? But if you went and talked to someone who, you know, like a Boeing, they'd be like, what are you guys doing? Why are you thinking about data this way? So we have a divergence happening now in the perspectives around data, which is sort of the old school world, and we have the new school world that's punctuated by the modern data stack and the cloud. So that's why I think it's happening, and why, even though I'm saying things that are not new, it probably is going to be new for a certain group of people that are listening to this podcast. So that's number one. The next question is, okay, how do you do this? It's really hard. It's hard to do upfront data definition. It's even harder to do upfront data definition if you're trying to convince a very fast-moving startup. And then who owns these things? Because there is, like you said, Tim, there's an inherent tension between the software engineer and the consumer. The first thing I think is important is there needs to exist some concept of a data contract. So an agreement between the software engineer and the data consumer that the engineer should care about the analytics use case. That's number one. And in the contract, we're talking about schema here. So it's either the schema of an entity, so what are the properties in this production table, or what we've been calling semantic events, like a real world concept, a thing happens. So in Convoy's case, it might be a shipment is canceled, a carrier signs up for our application, we send them a fuel card, they make a phone call. All of these are real world events. The great thing about that is you can tie the event and the entity directly to the service where the source data is generated. So you have very, very clear ownership over the source data. You have clear quality control. SLAs are handled by the engineers in that case. The definition of the data doesn't really have what I would call an owner. You have people, because more like you're basically just describing how the business operates, right? It's a map. I would say it's really akin to Figma. If you're familiar with that tool, it's a really great UX design tool. You can build out prototypes and mocks and all these things. If you're in Figma, there's not really an owner of the design on paper. It's an entity, it does exist, but the implementer of the user interface is always going to be the software engineer. So there's a second part to the question, which is, okay, that works when you're talking about this descriptive knowledge layer. So if you're describing the real world, then you really want to build this great pattern where the downstream consumer gets into the process of defining the data they need, creating a contract, passing it to a software engineer implements it, and they become quality control for that. But the next question is, well, what about all the rest of the stuff downstream? Like, we still have to do transformations. Like, we still have derived metrics and attributes that are important. And there's a couple different ways that you could go here, but I think this is where the value of a metrics layer starts to come in, right? What a metrics layer could do is say, we're going to consume this data that's coming from the knowledge layer. We're going to treat it like an API, and we're going to standardize it. And then teams can say, I have a single definition of margin, and I'm going to define it in a single layer. It flows through CI/CD. It has a review process. And in that way, there's very clear ownership of that particular metric that evolves over time. So if you're on the finance team, you should probably own the finance metrics. If you're on the shipper team, you should probably own the shipper metrics. You can do the same thing with dimensions and derived attributes and anything else. And the way that we've been thinking about this at Convoy, although we're still getting there, is that what we'd really like to have is an API of that essentially it's a cube. The backend doesn't particularly matter, but we provide all the different combinations of metrics and dimensions, and we pipe that into our downstream visualization tools. So what we enable in that world is the data consumers really care about defining the stuff they need. They care about defining like what this metric is. And then the consumer gets all of that for free and they can cut it however many ways they want.
All right. A lot to unpack here. But one of the things, so your perspective right now seems that it is biased towards you guys actually build your own software. So how does this work for companies who I'm just buying I'm buying an ERP system, CRM system, stuff like that? Everything you're saying, does it apply for those types of companies? Because here's the thing, is that first of all, not every company has a Google, Facebook, Amazon problems, and not every company is a tech company either. So I agree with you. But then if I'm playing devil's advocate, it's like you just described something that I'm never going to go do because you said the software engineers. Like I don't have software engineers. So are you in your own bubble, but which is a very well defined bubble with people really think about this that is fine or?
Well, I would say where this applies is to the folks that are strongly considering the modern data stack. If that's not your world, if you're not thinking about the modern data stack, if you're not thinking about ELT and Snowflake and doing a ton of transformations, if you're sort of still playing in this world of like, we still use Vertica, right? Or like we're still doing everything offline. We still have like we're still using Informatica. We have a set of data architects. You're going to be facing a completely different set of problems. But I don't know if data definition is going to be the biggest set of issues that you have. I think if you're starting to transition to the world of the cloud data warehouse of Databricks and Snowflake and Fivetran and DBT, that is when you're going to start bumping up against the issues that I'm talking about at scale. But in terms of your first question, which was, do you need to have a fleet of software engineers to go do this? And I think the answer to that is no. Everything that I just described, you may not be able to go and buy it off the shelf, but you can do it manually. If you're moving to this like definition first world where you do have an engineer that owns a service, like if that exists, if there's a thing called if you have either if you have microservices or if you have a monolith, and there's some set of engineers who own that, right? If that's not the world that you live in, then it's like none of this applies to you at all. But if you live in a world where software engineers own a monolith or microservices, and they have production tables that they care about, you have some point of sale system and you're doing fraud analytics or whatever it is that you want to do on that data. If that exists, then the way that it should be positioned is the software engineer is actually responsible for the data that flows from the production system into analytics or experimentation or machine learning. They have all the tools to do that today. It's not always straightforward and simple to do, but it does exist. So for example, if you want to own, schema management, there's tools like Protobuf and Avro that exist. If you want to have a definition surface for your data, Microsoft Excel, a Word document, all of that works. The tools can be stitched together and they are there. It's more about processes and culture, I think. Do you want to do this? And do the teams, do you have buy-in from the teams to go out and implement it in this way?
So I think you've hit a lot of good points here on sort of the ownership topic, on sort of the knowledge topic, and sort of the interfacing between these different layers here. You even brought up the concept of the metrics layer, the semantic layer as maybe being that contract interface. And obviously, if it's an API, then it's literally a contract interface, right? So I think that's super interesting. But I'd love to get even a little bit more specific on sort of going back to Juan's original questions. Like, so that what is the alternative? And you've mentioned protobuf and some of these other things as well. So like, what's your dream architecture sort of for the alternative? And just to make the question a little more complicated on you, maybe you could answer it in two ways. One is like, imagine you're starting from scratch, kind of like what's the right design from the beginning if you have such a luxury, right? But what if you're like using Fivetran and Snowflake and Looker or Tableau or something like that today, like, and that's your quote modern data stack? What do you do then if you want to embrace this kind of approach?
I think the ideal would be the same no matter what. My ideal is there exists another layer outside of the data warehouse. It doesn't really have anything to do with the data warehouse. It doesn't even necessarily know. It might do transformations. But I'll describe what sort of my vision here is and what we've been working on at Convoy. So I think that the ideal system is composed of 4 parts. The first part is the definition surface, or I call it the data design surface. So this is treating data as if it was a design function. That means you have to be able to like clearly specify schema. You have to indicate what type of data you need. Do I need entity data? Is this like a CRUD event that I care about? Do I need transactional data? Do I need clickstream data? What should the schema of that actually be? And what are the SLAs on this? Like how frequently do I need this data, and so on and so forth. It's a design function, and it comes from the business use cases. The second thing that you need is some implementation interface for engineers. Protobuf is something that I've mentioned. Avro is another one. We use a combination of a protobuf-like thing and also Kafka. So we stream this. So the handoff is, it's a library, an engineer gets that. It's similar to Mixpanel, except for services, right? And that type of thing, a lot of these tools already exist today. It's just stitching them together, like I said. So engineer can go into their service. They can really, really easily implement these events or like APIs that are wrappers for production tables. The third piece is a mapping layer. So it's something, and this might be a human being that sits, well, it probably has to be a human being, that sits in between the schema that is incoming from production and what the data consumer has defined that they need, right? And you want to make sure that those two things are actually linked up. If you're talking about entities changing, that's actually really important. Entities and services go through refactors very, very frequently. And so you want to ensure if there's ever like a, non-backwards compatible change, that mapping layer exists, so you're not breaking people. And then the fourth piece is the transformation layer. So my perspective is dbt is great, but I don't think it is the right tool for data people who are not data engineers. And what's happening more and more frequently is that non-data engineers are starting to get this hands on their tool because it's the fastest way that they can actually build their tables out. So I think dbt should actually be totally abstracted. You should have the transformations happen in that layer above, either totally abstracted from the data warehouse completely, like maybe you use a materialize, or it's like some KSQL thing and happens all through stream processing, or maybe it does happen in Snowflake, but it's not in a place where anybody can actually see it. And then what you're doing is dropping data marts into the data warehouse, right? Whether it's a cloud data warehouse or some like could be Databricks or Snowflake or Redshift or BigQuery or anything. And there's some element of governance there. So if I'm the shipper team, here's the stuff that my service team owns, right? My service team has implemented this in production. Here's all the data. We're treating this like an API. Technically, like that's basically the data product. We know where that is, and no person in the organization is going to be able to come in and add like additional properties onto that without, some type of sign off and review. In that world, what you get is extremely trusted data. It's comprehensive. It's changing iteratively. The data quality is all pushed to the right person. And it's very, very easy to then transform it simply through like select statements. Like if I want a metric, most of the time what I'm doing is I'm just writing a select statement and I'm aggregating an event. That's my ideal world.
Okay, so I'm going to repeat this back because I got some questions and I'm actually a bit confused on some things. So definition source, definition surface, your design surface. Basically, go define your schema, your target schema, your ontology. That's what it is.
Yep.
The bubbles and lines that you draw on the whiteboard that the business users understand. That's number one. The mapping, let me jump to the third one you said is a mapping layer, which is usually a human who's going to sit down saying, okay, this is the bubbles and lines. That's the layer that the business people understand. I'm getting this data from this source, whatever it is. That could be something that that the software engineers built, or this is the CRM system that I have, whatever. I need to understand how foo maps to the foo is first name and bar is last name or whatever, right?
Exactly.
Okay. So that's the mapping layer, and that's kind of the human literally just saying, hey, A is equal to B here, and I'm probably saving that somewhere, right? Then I need to actually implement that mapping, right? I need to, and that implementation is that second layer that you said, right? Implementation interface for engineers, right? Yes. So that's where I'm like, okay, now that I have the function that says that foo equals to first name, like I need to make that computable, and I'm going to go implement that.
Correct.
I got those three things. My confusion is, so where is the transformation layer like the DBT thing come in? Because one could argue that if my sources are all relational tabular, that implementation thing that I just talked about could just be DBT.
It could. So there's a few ways. So one of the things.
By the way, or it could be just regular SQL. Or
it could just be regular SQL. One of the things that that we've been thinking about a lot as far as a transformation layer at Convoy is, if you're doing this definition of like the ideal world up front, you don't necessarily need to stop there. You can also describe like, how do we want the data warehouse itself to manifest? Like, what should the tables look like? How do we want to aggregate these events to some entity? And in that world, like, you could define that through some config in the descriptive layer, and then the transformations can happen, and it can all be automated because the mapping has occurred and you know how you want to build it. So when I'm talking about a transformation layer, what I'm saying is you actually are constructing the data warehouse, and you're not just dropping like, raw JSON events into some like source table somewhere.
All right. So to get very specific on this, and because I'm very aligned with this. This is how I've seen the world. I call it, you define your ontology, right? This is how the business defines it. You have that's your target, right? Just traditional data integration speak from the 2000s. You have your source, you have your mappings. You're gonna go define these mappings. A lot of the work, even from the academic world, I did this stuff too, is trying how to automatically generate mappings from source to target, and that's so much work there, which it's so hard to actually do automatically because you need people involved.
Right.
All right. So I do that. Then I need to go implement these things. Now, what I can imagine is that the implementation of that, if I were to literally run the code, I would be generating data that represents that particular entity. So the example I always talk about is you have an order, you have a customer, you have an order line. My graph says a customer places an order has an order line. An order line includes products, right? So if I put this all together, and my data comes from all these different sources, if I put all this stuff together, kind of the first step that should come out is a data product, which could be looked at as a table for orders, which is a table called order with a bunch of attributes for that. A table called customer with a bunch of attributes for that. You probably know what the join keys is around these things and so forth.
Yep.
Now, those are it's the standard e-commerce database schema that you read in every database textbook that you would expect it to show up in a database, but it never does. So you're trying to just recreate that. And that's your semantic layer. It's called a tabular semantic layer. That way it's manifested as tables. Then there could be some joining, some transformations that could occur over that for, I don't know which reasons, but let's assume you need that. I think that's where a transformation thing like a DBT would come in.
Correct.
And then there's your semantic knowledge layer. People can go in. This is well governed. This table represents orders. This table represents shipped orders, and this is by the shipping department. And you can only the shipping folks make those changes over there. Now, that's a semantic layer. So when the metrics layer comes in, if we got this all right, every metric the implementation on any metric should probably be 5 lines of SQL.
Exactly.
10 is probably way too much.
Exactly right.
All you're doing is joining 1, 2, 3 tables and doing some sort of aggregation. I'm joining the orders with the order lines with the product and the customer. So I know exactly what products are bought by a customer. I'll filter by dates and I have some aggregation. That was the metric I could go do. I can go filter on some of the categories on the different types I can do. Anybody now open up as in Tableau, you know exactly what this means. You can't get more complicated.
Exactly. And to even build on sort of your last point is, if you've really done this well, you could work in objects instead of code. Like if you inherit all of these things from the, I mean, we call it semantic layer, descriptive layer, whatever. But if you're inheriting objects, you don't even necessarily need the code. You can say, okay, I have these objects, I have this entity, I have like these like metric concepts, and now I can just sort of combine them however I want in a very easily way. It's like, okay, here's my costs, here's my revenue. I'm just going to combine those together. And now I have this concept called like margin.
This is what I've been working towards my adult career.
Great.
My PhD title is integrating relational databases with semantic web. And do exactly this, right? We've did these standards. I mean, it's all for the RDF stack and everything. Heck, I've written the standards for doing mappings of these things. Anyways.
I think just to chime in on your excitement and also some nostalgia, Juan, like I think folks that have been thinking about this problem for a while are excited about this newfound, like semantic layer and metrics layer. It's like, oh wow, this looks kind of like the new reinvention of kind of the things we've been talking about, but now the cool kids are talking about it. Yeah, this is good. But then I think the skeptical part, I'm going to channel the skeptical Juan here. Skeptical Juan is like, here we go again. Like we tried it before and we're going to make the same mistakes again. Right. Maybe as a final question to you, Chad, before we move to lightning round and that kind of thing, like how do we make sure the right future happens here?
So I think this sort of comes back to first principles, and it's worth asking the question, okay, we had these really great systems that already existed. Like, why didn't they take off with the modern breed of tech company? And I think what it fundamentally comes down to is speed. They're just too slow. You have to have a heavy governance layer. It's hard to change. You have to hire like roles that are like IT related specifically to handling like products that run these types of things. Like it's very, very, very slow. So I think that the key is to make this fast, is to make it iterative. And the great thing is we've learned about how to do that already. There's a lot of really great systems that exist that do this well. GitHub does it well. I've been talking about Figma. Figma does it for design, and they've done that by doing it through the cloud. It's version control, it's collaboration, it's instead of having this like heavy governance layer, it's like peer review, It's like the equivalent of a PR where the people who really care about something are the ones, like they're the ones who look at it. Could be data scientists, could be software engineers, could be product managers, could be business people, but there's more of a community effort on reviewing and evolving this thing iteratively instead of bottlenecking it on like 5 or 6 people at the company that are responsible for this massive beast. I think that the speed is the core reason why it didn't take off. And if we can solve that for the cloud, I think a lot of people are going to start adopting this approach. That's my perspective.
So it's not just the idea itself that is inherently causing the friction here. It's let's wrap collaborating around this metrics layer, semantics layer, and sort of the through line that connects the mappings and the transformations. Let's wrap that with an agile, collaborative, modern experience. Then it could take off.
Exactly. This is going to be a question that comes up, and we're going to talk about data mesh more. But I think a lot of people really, I come more from the product side, and then I started getting involved in data. And one of the things that you learn as a product person is friction is the killer of everything. If a process is hard, if it's painful, and if it's slow, people will always take the path of least resistance all the time. And so the only way that you can incentivize folks to do the right thing is if you make it easy. and if you make it fast and you make it simple, and it has to map to the mental model of the CEO and all the executives.
That's the main takeaway. Got to make it fast. Which I think there's a balance to figure out of getting it done correctly, because you do fast and we go back to the old ways of like, that's what Google's were doing. But we got to talk more. We got to go to our lightning round. So let's move on to the lightning round, which is presented by Data.World. Again, every Wednesday we get to do this thanks to Data.World. So, all right, I go first question. If you're familiar with Dave McComb's data-centric architecture, do you feel that your ideal world aligned with the data-centric architecture concept?
I think it does. I mean, one of the things I've been talking about a lot internally is like, this is, domain-driven design, and I think it's data first. But my idea, I talked about my ideal in terms of like a product framework, but my hyper ideal in terms of a worldview is that instead of building out services first and expecting the data to follow, the data is actually what drives the development of the services. The services and the product map to the data architecture, not the other way around.
Well, me, I would say it's not data first, it's knowledge first. Everything you've been talking about here is about understanding these models, what this stuff means, and the people and the context. All right, Tim, your turn.
Yeah, sure. So next question is the runaway train of the modern data stack moving too fast? There's no stopping it now.
Well, no. I think that what's going to happen over the next 5 to 10 years as the modern data stack continues to grow is that people and teams will hit their limit. They will hit their limit in terms of spend, computational spend. The number of transforms happening downstream is going to become insane. Your Snowflake bill is going to balloon like crazy. The headcount you're going to need to maintain such a system is going to explode. And the incremental ROI of each data headcount is going to be flat to negative. And teams will hit this. It's not a matter of if it's going to happen, it will happen 100%. And when that happens, there will be a motivation to change the processes.
Fully agreed on that. This was a conversation we were having with Mohammed Asser at our summit. It was like, how do you scale this stuff? You need to have the knowledge layer. The number of questions that we need are going to outgrow so fast. It already has the data teams, period. You need to have a way to go scale this, the knowledge.
A lot of people aren't thinking about this right now, right? They look at the past and they say, "Oh, look at that like SQL Informatica hairball. Oh, like we're never going to do that again." And then over here, maybe they're building the new hairball, right?
I got the next one. Will the current hype around metrics layers or semantics layers lead to the right solution you proposed today?
I do think metric layers are important. Like you said, in the ideal world, it's very light. I think they need to be there. And I think it's possible that it pushes the conversation upstream. Like if people start to if you're like, okay, we're building out these DBT models, we're starting to build metrics on top of that, we're using a command line, and that's kind of hard. How do we make this easier, right? How do we make it simpler? I think a lot of these questions are eventually going to lead us, like all roads basically lead back to the knowledge layer. So it will be a great conversation starter. I don't think it will be particularly harmful. Any sort of semantic conversation, I think, is helpful. But we're just not quite there yet as a community. It will take some time.
I love that. All roads lead to the knowledge layer.
Yeah.
Tim, take us away. Last one.
All right. Fourth question. Last question. Is the analytics engineer the new data architect?
Probably. I'm in sort of two minds on that. Honestly, I'm kind of. I wouldn't say I'm holding my breath or not holding my breath. I would love to get some more hands-on experience with how it goes. On one hand, you do have like, okay, maybe there should be somebody who is basically like this data designer, data architect role, and they're embedded and they're thinking about the organization like all the organization and management of the schemas for like their particular teams that they work with. But on the other hand, is it possible that that you don't need that, right? Is it possible that someone can just say, well, here's the things that I need, and in order to get the things that I need, like I'm gonna need to add this key somewhere. Like I need to join on this ID. I don't need to have another role design that for me. I know what I need in order to answer this question. I don't know what's going to happen there. I think this is still so new that we're just going to have to wait and see for like a couple years.
All right.
I love your perspective there.
Mesh minute. I got timer. 1 minute to pontificate, opine, rant about the data mesh. Ready, set, go.
I think that the data mesh is a really, really interesting idea, but I wish that people would take more of a problems-focused approach. And instead of saying data mesh sounds cool and it seems like it would be great and it would do this, that, or the other, saying what are the top problems the business that I'm working with has right now as far as data quality, organization, and management goes, and how do I solve that problem first? I think it's going to be really, really difficult to generate the right kind of organizational momentum to drive data mesh unilaterally across all but like the most technology savvy, mature companies. I think that's my perspective. Start with the problems first, solve that. And then if data mesh works for you, then you can do it.
Perfect. Right on time too. I agree. We always say create a backlog. We got to catalog the questions people have. But
yeah.
All right. Tim, take us away with your takeaways.
We'll take us away with some takeaways from the takeaways. So we talked today about the modern data stack and how, while it may solve some problems, it creates a lot of problems as well. And perhaps some problems that we've seen in history that have plagued us, that have caused us trouble. And you mentioned really importantly that if you're building on top of a swamp, that's not a good foundation. Your buildings are going to sink, right? So, there's this perspective that seems to have led to the formation of the modern data stack. You could probably even, make the same analogy to the big data stack, which kind of was the predecessor to the modern data stack, right? Sort of we've been looking at the FANG companies and kind of seeing what they've been doing, and saying, oh, well, that maybe that's the pattern, maybe that's the right thing to do. When in reality, they were building out as many services as they could, as fast as they could, making as much money as they could, and then kind of data became the afterthought. Like, how do we come back and now address the data in a way that how do we reverse engineer our business concepts from the data versus taking a business concept first approach. So simply looking to them for guidance is not the right thing here. You also talked about how, data consumers and data producers have this gap, and you have to be able to bring them together. And one way to do that is this idea of data contracts, right? And how can we use that as a way to create more of an agreement between them? And you talked about, sort of, Juan asked, like, where's the knowledge going to live? Where's the ownership going to live? You mentioned that the knowledge is going to live sort of in this knowledge layer, this descriptive layer. And one thing you can look at in the past that sort of a lost art is this idea of like the entity relationship diagram as a way to sort of model, hey, here's my business concepts, here's how they hang together. Obviously, there's like, graph modeling concepts and things like that, which also can be great with this kind of thing. And then ownership, right? That the business, the consumers should really be defining what it is that the data, should be doing for them, so that contract can be established upstream. So, so many more notes, but I'll pass it to you, Juan. Well, what were your big takeaways?
So when we talked about data contracts also, so an agreement between the engineers, the data producers, the consumers, right? Start thinking about the schemas as an entity. I like how you said this, these events, these are things that are actually happening today within our business. In reality, we need to have this map of the business. And I think so we talked a lot about the pains about the modern data stack. So what is the alternative around this, right? Your vision, these 4 parts, that definition surface, the data design, right? What I call this, that's the knowledge. That's actually the actual semantic knowledge or the ontology right there. The mapping layer, right? Where the human sits down and figures out the mappings of how these things from the source and the target connected. This needs to be then implemented, right? And then 4th, you may want to have some other transformations after the case. I personally believe main things are those first 3 that I said. The transformations may come afterwards. But at the result of this is that you're going to have that trusted data. This is the shipping data, the shipping of orders that the shipping domain owns, and they have the responsibility for that. Now, this isn't new, as we've talked. Why didn't this approach come up before? Why didn't it work before? It's speed. It's been slow, right? We need to make it fast. We need to be able to iterate it. We need to have to use tools, modern tools like version control, things in the cloud. And if we don't make it easy, people will take the path of least resistance. What I always say is we can't boil the ocean, right? And I think part of the issues of the past is that we've been trying to go do the whole thing. Boiling the ocean, we need to go have this based on the very specific questions we want to go do. Something we did not get into, which is an interesting discussion for later on, a different podcast will do this again, is how do we balance this fast versus getting the knowledge, right? Because it seems like it can and will interfere. Something we need to go discuss for our next one. All right. How did we do? Good takeaways?
Did great.
All right. So back to you quickly. 1, what's your advice? 2nd, who should we invite next?
For my advice, one thing that I would really recommend any data team out there to do is it can become very easy to fall into the trap of continuous optimization of a bad system instead of rethinking the existing system. And that's hard, but it requires going to the people who are using the data, asking them what their problems are, getting a really, really good understanding of their needs, and then coming up with the best solution to solve that set of problems. So that would be my advice. I hope more data teams start following it and really thinking like a product team that's facing a third-party customer, treating those data people, treating those data scientists and analysts and everybody else as if they were customers.
Amen.
Amen. Yes. In terms of who to ask on next, I'm going to say Chetan Sharma or Che. Che is an awesome guy. He is a founder. He thinks about experimentation. I used to work in experimentation, and it was actually experimentation that led me to a lot of these thoughts, because there's a really tight interplay between the source of the data, the engineers that are implementing the code, how the data is transformed into metrics, and how the business users are analyzing it. It's a really concise end-to-end view. And so he has some great perspectives on this stuff as well.
Awesome. Oh man, this has been an awesome conversation. I knew this was going to be, this is what we needed. We needed this fresh air, and I'm looking forward to hearing what everybody else is going to be saying about you, Chad. I'm going to continue being a Chad. Hater is not the word. It's not the word I wanted.
Engaged discourse.
Engaged. It's okay. Haters are my motivators.
Okay. Well, before we wrap up, next week we have Steve Perry, who's the director of the analytics from Genius Sports. We're gonna have a very special episode with Steve, because Steve actually reached out to us as a listener, and he's like, "Hey, we love what all the guests, but I would love if you could touch some topics about kind of being young in the data space and up and coming data leader." And we're like, we just had an awesome conversation with him. We are going to just have a true, honest, no BS discussion about how to deal with the noise in this space, how to deal with imposter syndromes when you're going in, like, who do I talk to? How do I get mentors? Stuff like that. And I mean, I'm really excited about having a different kind of conversation about data. And we're going to be at the Knowledge Graph Conference the week of May 3rd, I think it is. And we'll have a live session with Francois Scharf at the Knowledge Graph Conference. With that, always thanks to Data.World for supporting us. And thank you, Chad. Thank you so much.
Thank you.
Cheers.